So yeah, 6.6 summary factoring is just review. Okay, so I may take some shortcuts in this. You could factor by grouping if you wanted to. With any of this stuff, there's not like a required method to solve these though. But if I see a nice shortcut, then I'm going to take it just because it looks like we got a lot of stuff to cover. Well, a lot of slides. So yeah, factoring by grouping, we've seen that. Again, you usually have the four terms, and then you take the middle term, which is usually just the x term, some kind of x term, and then you look to split it up between two values that would be, that would add up together to be this middle coefficient. But you're looking at the constant usually, or the product of the leading coefficient and the constant to see what factors together would add up to be this middle coefficient. That's what these two numbers are. Again, I think that's stuff that we've already seen. If we see that we're looking at a trinomial like this where the coefficient is a phantom 1, then we're going to do that. We're going to look at factor pairs of the constant to see what those two values are that add up to this middle coefficient. That's what I was just barely talking about. And then you just pretty much fill in these, whatever those values are, as these two values. Doesn't matter which order you put them in either. Now, if there is a non-1 coefficient of x squared, then we'll multiply the a and c, and then we'll look at factors of that product whose sum is the middle coefficient b. Okay, so that, it just, I wouldn't say it's even a slight complication. It's just a little bit of a complication there. And again, with all of this factoring stuff, we should always be looking for a greatest common factor that can be factored out of all of the terms. Now, if it's a trinomial, we'd look for all three terms. If we look at any expressions that are polynomials, usually 4 terms, then we'll either look to see if there's 2 terms that can be combined to make it a trinomial, or we'll look to factor by grouping specifically at that point. Yeah, then we got these perfect square trinomials. And again, when we do this, my habit is to look for at the first term and the last term and see if there's any perfect squares in there. Which, by the way, a 1 is a perfect square. So if it's showing a phantom 1 like it is on this one, then you'd say, well, it still could possibly be a perfect square trinomial. And then if we end up with something squared minus something else squared, again, we're looking for usually perfect squares at that point, then we'll look to use a difference of 2 squares then. Once again, always first looking for greatest common factors. So all that stuff is stuff that we have seen, right? Like this one, we see that really what we have here is 2 terms. We got the 13x times x minus 16. That's 1 term. And then this other term is 2 multiplied by the quantity x minus 16. But one thing I hope that we all notice at this point is that we have an x minus 16 factor for both of these terms. So I'm going to yank that out of both terms like this, and then I'm going to put in parentheses whatever was left over. So I'd say first off I have this 13x there. You could pretty much even call it a coefficient, and then that's a positive 2 because of the plus sign, so plus 2, boom. That's it right there. So I don't really consider that a shortcut. It's just this one kind of started in this format, which allowed us to do that. There's a greatest common factor in both terms just to start out. But then we see something like this, and I think I said this when we went over this lesson, but I see, just to start out, that there's an x cubed in this trinomial, right? And so I would kind of be expecting to factor out an x cubed from each of the other 2 terms. Because as we've seen, the general format for us is usually ax squared plus bx plus c. But the c doesn't usually have any x factors in there. So this one is showing an x cubed. So I can see that there's enough x's here, x cubes, 3 x's there, to take out of all 3 of the terms, right? So I'll actually move it over here just a little bit. So from each of these terms, I'm going to remove an x cubed. Now I'm just focusing on the letters right now, the variables. So if I took away 3 of these x's from these 6 x's being multiplied together, I would be left with 3 of those x's, okay? I pretty much, since I took 3 out of it, it's like 6 minus 3, right? Like we've seen with our exponent rules. But I'm going to do the same thing with this x to the power 4. These 4x's multiplied together. I just took out 3 of them, so I'm just left with one individual x. And then these 3 x's, of course, they were all removed. Okay? So let's see how this goes. Okay, so next up, I see that all of the terms, 28, 12, and 20, they're at least divisible by 2. But if you think further into that, they're all divisible by 4, actually. So I could say, well, I'm going to yank out a 4 from each of these. So then say, just divide each of these by 4. And what are you left with? 28 divided by 4, I'll start on the left there, is 7. 12 divided by 4 would be positive 3. And then 20 divided by 4 would be positive 5. Now, I was kind of expecting this to be an x squared to give us a kind of a trinomial factoring thing to work with, but we can't look to factor anymore because of this exponent of 3 right there. Okay, remember, everything that we've been seeing is something x squared plus something x plus some kind of constant right there, but this is cubed, so we shouldn't be looking right now for any other factoring at this point. In any case, this one was just factoring out a greatest common factor. So there we go. All right, here we go. So this one, we got a nice polynomial, right? And you see, even right here in the middle, you could say, I'm going to combine these two terms right there, which you could, but they're all x squareds right there. Maybe I should even backtrack just a little bit on this one and say, see how this final term right here has the x? So just with all 4 terms, I know right now that I can take out an x from all 4 terms, right? So let's go ahead and do that, see what happens. And again, I'm ignoring the numbers. I know some of you noticed something about the numbers. We'll get there. But if I take out an x from each of the 4 terms, then my x cubed will then be an x squared. Okay, so that was just from the first term. The next term has an x squared, but we just took out an x, which is going to leave it with an x. Same with the next term as well. That had 2 x's multiplied, but now it's just 1 left over after we factored out this x. And then this final term, of course, we took away the x from there, okay? Now I would look at the numbers and just see if there's a common factor with all the numbers. And I see that they are all divisible by 3. So I'm going to yank out a 3 from each of the terms as well, okay? So starting from the left, I'd say 15 divided by 3, that'd be 5. This is negative 30 divided by 3, which is now negative 10. And then 9 divided by 3 there would be positive 3. And then finally this negative 18 divided by 3 would be negative 6. And of course, we removed the x, right? We factored it out here. So this is all I have on the inside. Okay, now, like I said, you could look to combine the x's even at this point, but I'm going to keep them separated, which I'm kind of assuming they're doing this on purpose, so that we can factor by grouping, okay? So let's go ahead and do that. And yeah, I don't see any other factors that I could take out that are common from all 4 terms. So let's go ahead and do that. So I'm going to look at this first set, okay? And I'm still operating inside really a larger set of parentheses here with the 3x out in the front. So I'm going to put it out there just so I don't forget later, but you could wait if you wanted to. So I see that both these terms have an x that I could yank out right there, right? But they're both divisible by 5 as well. So I'm going to yank out a 5. What am I left with? So from the 5x squared, we pulled out the 5, we pulled out an x, so we're just left with an x. Okay, what about negative 10x? Well, we pulled out the x, and then negative 10, we pulled out 5, so that'd be negative 10 divided by 5, which is negative 2. Okay, so that is factoring out the first, of course, we made it a binomial right there, but that's the first binomial. Next, we will factor out from this binomial. Looks like I can factor out a 3 from there. That's a positive 3, so I'll show plus. And then what's left on the inside? Of course, this first term, you yanked out the 3, so we're left with the x. And then the negative 6 divided by 3 is now, negative 2. Yeah. Now, we talked about this during the lessons for these types, but this x minus 2, we pretty much should have expected this one also to be x minus 2, which it is. So now I can split these, right? I can say, look, I got the x minus 2 that I can factor out of both, and you can even show this in a larger set of parentheses if you'd like. But then we have another set of parentheses with whatever was left, such as the 5x in green and the positive 3 in orange. And yes, we still got the 3x out there in the front. Now, at this point, I would want to take away the parentheses, more because I'm a math nerd and that this makes me feel like it looks more pretty, but I don't see that there's any other factor. Remember, the last thing we should always look at is to see, especially within each set of parentheses here, each binomial, factor, if there's anything that we can factor out, any greatest common factor between the two. I don't see any. So that looks like it's good to me. And remember as well that the order of these doesn't matter. You could have made the 5x plus 3 here and the x minus 2 there. Generally speaking, they want the 3x out in the front, but you could put it towards the back end here too, and I think you'll get full credit. All right, this one looks interesting. So take a shot at this one, okay? Try this one out, then we'll go over it together. Now, the first thing I notice on this one is that we got some coefficients that are, these two first coefficients are 7. That makes me think that this is divisible by 7. I put it in the calculator just to check, and it is, okay? So I know in the other problems I start with the letters, but it's just because 7 is prime, I'm kind of looking to see if this one's divisible by 7, okay? Like I said, it is. So that means I can yank out of each term at least a 7, okay? Now, this 7 divided by 7, I'll put the 1 there to hold its location in the term. And same with the next term. That'd be like a negative 7 divided by 7. That's negative 1, okay? And then I have this negative 294, and in my calculator, I divided that by 7 to get negative 42, okay? So just numerically, if you were to distribute 7 into all 3 terms, you would end up with the same numbers that we had in the original expression. Now, having taken a look at that, that's good. And then I see a squared b, ab, and then b in all 3 terms. There's not an a that's common, but I do see a b that is common, so I'm going to yank out a b from each of the terms. Okay, so really all that does is it kind of just eliminates the b's from all the terms, okay? And then, of course, like I said, we got the a's, right? In the first term, we got a squared. In the second term, you got an a, but there wasn't an a in the third term to make it common to factor out, okay? At this point, I'm going to make those phantom ones. You know what? I'll keep the middle one of non-phantom one. What the heck? I'll keep it like this. All right, so again, if you were to distribute the 7b back into this parentheses, you'd get the exact same expression that we started with. Now, at this point, I see that the leading coefficient is 1, which means that I'm just looking at negative 42 to see if I can find any 2 factors, a factor pair of negative 42 that would add up to, in this case, negative 1. Okay? So negative 42, of course, 1 and 42 would be there, but adding those together is no good. And yes, one of them has to be negative because it was a negative 42. But even 1 minus 42, okay, that's negative 41, or negative 1 plus 42, that would have been positive 41, right? So that's no good. How about 2 and 21? No. It's not really close either. It's not, it is divisible by 3. 3 would be 14. Okay, so that's still not very close in either direction there. It's not divisible by 4, 5, but it is divisible by 6. 6 times 7. Okay, there we go. Now, we need this sum, right, because we are going to add these together, but we need the sum to be a negative 1. So if that's the case, we need the 7, the bigger number, to be negative in this case. All right, so I'm going to show this as positive 6 and negative 7. And like I said, since this is kind of a review, you could use factoring by grouping, but I'm going to use the rule on this one, where I'm going to place my x's, and then the 2 factors, positive 6 and negative 7, would go into the 2 binomials. And yeah, we still got the 7b out there in the front. Okay, so a little sloppy there in the top corner, but this is what we're looking for. Boom. And again, the order doesn't matter. You could put this one over here. That's not to the power of 6, by the way. It's just my work. Again, sorry for the sloppiness. Yes, the x's are supposed to be a's. So let's, make sure you don't make the same mistake like I just did. I know subconsciously I really wanted those to be x's, but can't always have your way, My bad. So this one, we're going to work the same way with this one, okay? And yeah, 66 and 366, they're all divisible by 3, okay? So I know, just starting off, that I can yank out from each of the three terms a 3. Okay, so again, that's just like saying I'm going to divide all the terms by 3. I know I showed it a little bit different, but I'm trying to save a little bit of time here. So this 3 divided by 3 in the first term would be 1. 66 divided by 3. You can use a calculator here. It'd give me 22, and then 363 would be 121 right there, okay? Then you can look at the letters. You could have started with the letters if you'd like, but I can see that there's no other a's in this third term to factor out an a from all the terms. So we're just going to keep them there, right? Got a squared, that's a positive 22a, and then plus 121. That's pretty good. Now, the leading coefficient being a 1, in fact, I'll make it a phantom 1. Yeah, we're going to look at the same thing that we did on the last problem. I'm looking for any two factors of 121 that would add up to 22, okay? Now, even before I do that, one thing, which is, again, it's kind of a shortcut here, but I see 121 is the same as 11 squared, and a squared would be like a squared like this, okay? So since I see that the first term and the third term are both perfect squares, and maybe the 1 would have helped right there, I can look to the middle term and see if it's double those two values, right? So it'd be like 2 times 11 times a, and it is, right? If I multiply those two together, I get 22. So I got a plus sign and a plus sign there. That's actually kind of important right there, the 2 plus signs, because this goes back into what we saw. Let's see if I can fit it up here. Remember that a squared plus 2ab plus b squared? Yeah, that gives us the a plus b binomial, but it's squared. So that's all I'm going to do here. I'm going to take my a value. It's a plus sign between because of this plus sign out here in the front. And the two terms that I have are a, didn't forget the a this time, and then the 11. Just don't forget your 3 out there in the front. And again, don't forget a square there at the top, because I almost did just right there. Boom, this is it. And again, that saves us some of the factoring by grouping. Now, if you'd split the 121 up, you would have found the same two factors, 11 and 11. And so you would have ended up with the same answer either way. So yeah, this one happened to be a perfect square trinomial. Again, the main idea here was that there was a plus sign between the first and second term, just like we had here, which made this a plus in the binomial. This one, okay, this one's nice. Well, we'll see, actually. So, first thing I noticed on this one, we got different letters in both terms, and it's already a subtraction sign. So what I would kind of anticipate on this one is the difference of two squares business, right? That was where you had a squared minus b squared like this, and then it results in two binomials with minus and plus. You could say plus and minus between the two a and b values like this. Remember this rule right here? Difference of two squares. The problem with this is that 50 is not a perfect square and 32 is not a perfect square. I mean, you can square root them if you'd like. So we couldn't go directly to this rule. What we should notice, though, is that 50 and 32 have a common factor that we can divide each of them by. Okay, and that's just 2. Okay, so if I divide 50 by 2, then it would become 25a squared. Of course, we got the minus sign, and then 32 divided by 2 would be 16b squared. That factoring out of the 2 here doesn't affect the a or the b. And now, yeah, we got 25 is a perfect square, so we can look at this as though it's a squared, and then 16 is a perfect square for the kind of the b term right there. And so I'm going to add a little bit of an extra step here like we did before, but I'm looking for this squared minus this squared, right? So what would that be? Well, 25, you could say square rooted, that'd be 5. Really, it's 5a squared, because if you square the 5 and the a, you get 25a squared. Now, the 16b squared, though, would be 4b, okay? Because if you square 4b, you'd get 16b squared. I'm not worried about the minus sign making that term a negative. Then we got the leading 2 out there in the front, okay? But this then is the difference of two squares situation. So I'm going to look at creating the two binomials, one with subtraction, one with addition between the two values, 5a and also for B. That's a B. Yeah, so let's take that 5A as well, 5A and 4B with the plus sign between. And again, don't forget that 2 that we factored out in the beginning, that rate is common factor 2. But that's it. So how about this one? Well, this one's got a plus sign between the 2, so this is definitely not a difference of 2 squares. Yeah, so I probably wouldn't look at anything beyond this, or beyond greatest common factor for this one, okay? But I do notice that the 50 and the 8, they're both divisible by 2. So let's take or factor out a 2 from both of those terms. So 50 divided by 2 would be 25. And 8 divided by 2 would be 4. Of course, you still got the x squared and the plus sign and the y squared. Now, if this was a subtraction sign, I'd be looking for a difference of squares business. Or even if this was just an x squared kind of thing. Even though 25 and 4 are perfect squares, this is not one that we can do right now with real numbers. You could do this with imaginary numbers, but we don't really care about that right now. So this one actually is, it's just done. But again, keep in mind in the future, you'll find ways to factor this out, but right now we don't care. So this one's giving us a polynomial, right? We got these 4 terms. So kind of the first thing I would look to do on this is to see if I can factor out any greatest common factors, and I don't from all 4 terms, right? You got some numbers. A 2 is not divisible by 7, although 49 is. And there's no x or y variables that are common with all 4 terms. So I can't look for any greatest common factors here right now. But since it's coming to me already in a polynomial with 4 terms, I'm going to look to factor by grouping. First this grouping, and then second this one. And then, like I said before, you can just put a plus sign between there if that helps, okay? So from the red set of parentheses, I can see that I can factor out a y. Oh, looks like that's it, actually. So what's left on the inside? You got x squared minus 49, right? Because we got kind of pulled these y's out there for this one. Okay, and now this next binomial, this is a negative 2 to start out with. This is a leading term there. And so I'm going to at least yank out a negative 2 from that one, okay? So I'm going to yank out a negative 2. I don't see that I can pull out an x from either term as well. So what are we left with on the inside here? No surprises, x squared. And then this would be, because we pulled out a negative 2, it's 98 divided by negative 2, which is now negative 49. And like we said before, we're kind of looking to see a match between what I have in the red parentheses and now the purple parentheses, right? So what do we got then? Well, I got this x squared minus 49 from both of the terms. And then what do I got left? Well, we got y minus 2. Well, y and negative 2, so y minus 2, okay? So something like this. And that's pretty good. You know, you get to this point, if this was an exam, you went to this point, at least half credit, maybe 3 out of 5 points, okay? But there's one extra step. This is the difference of 2 squares right here. So just to show that rule up here in the top left, see if I can fit it in there. All right, that's one of those a squared minus b squared situation is a minus b and a plus b quantities, like this, right? So that's what I'm looking at on this one. So I'm gonna, I want to see what that would be. Squared, right? Something squared and something squared. Well, the first term here is just x squared. The second one, that's 49. If you square root of that, you'd see that it's a 7, so it's really 7 squared. Because 49 is a perfect square. Now, this is kind of an unusual perfect square for us while we're trying to get used to perfect squares, but it's there. And if you ever see an x squared minus something, you may just want to check to make sure to see if that one can be square rooted. And you can do that in the calculator. All you got to do is push second and then the button immediately to the left of 7. That's the x squared button. That'll give you the square root. Punch in 49, enter, and it will tell you the square root of 49 is 7, okay? Now, that may be getting a little ahead of ourselves, but in any case, this then breaks up into the 2 binomials from the difference of 2 perfect squares right here with subtraction and addition. Again, the order of those doesn't matter, but we got the x's as the A terms and the 7s as the B terms. And then like we already had, we got this y minus 2 stuff here, okay? And now that would be considered full credit, fully factored polynomial. Now, if you wanted to do this, not that I think anyone really wants to, you could actually distribute everything back into each other, and you'd see that eventually you'd end up with the same polynomial that we had started with. So I did put the 7 in parentheses. Since there was only one factor there, you could say, well, you could take that away. Now, that's not going to change anything, right? Still 7, that is your B term on this one when you're using this difference of 2 square business up here. But I like to put the parentheses there really just to clarify that that is by itself the B term, the B value. So this one, yeah, factor this out. Hey, look, this one, again, if you got something x squared, and then, of course, the coefficient here is a phantom 1, which is a perfect square, by the way, but subtraction. So, yeah, once again, we're looking at the difference of squares here. A squared minus B squared is, we're going to split this up into the 2 binomials with subtraction and plus between A and B on this, right? So what is my A value on this one? So that's x, right, to the power of 2 on this one. Let's kind of set this up. So it's the x to the power of 2. And then the 36, that would be 6 to the power of 2. Now, if that calculator stuff, like you're struggling to find the buttons there, just 36, it shouldn't be a difficult number, especially if you got your multiplication table memorized. Just think to yourself, what times itself is 36? Because 36 isn't so unusual. I mean, if I saw like 196, okay, that's a little different. But 36, that's not too bad, okay? So we're looking at the 2 binomials here. So, yeah, so we got subtraction and addition. And the first term there is going to be x for both of these, and then the second term is 6. Okay, so x minus 6, x plus 6, boom, we did it. Difference of 2 squares kind of thing there. Now, we did talk about, just as a quick review, I'm not going to go through it completely. Yeah. But, you know, if you were like, couldn't you use factoring by grouping on this one? And the answer is yes. As long as you remember that between the x squared and the negative 36 is a plus 0x. If you do it like this, you can still factor by grouping and get the same exact answer.